I'm Russ Strader of Data Communication Brokers Incorporated. The number of computers used in business is growing daily, and as the number of computers grows, so does the need to move information from one computer to another. Making different terminals and computers talk to each other often requires a process known as protocol conversion. In this session, we'll explore the concept of protocol conversion and show you how a protocol converter can greatly expand your communications options and flexibility.
Let's start with a look at what we mean by protocol. Computers and terminals talk to each other in very precise ways. Data, which is transmitted as strings of ones and zeros, must be encoded and decoded according to rules that make the data meaningful to the receiving machine. This packaging convention, or protocol, is the handshake between computers that is required before data can be exchanged. Some common computer protocols are single ASCII character, 2780-3780 RJE batch protocol, 3270 BISYNC and SNA SDLC protocol, Burroughs Pole Select, X25, and the 5251 protocol for IBM System 34, System 36, and System 38. These protocols have developed over the years as the computer industry grew. Different protocols were developed for a variety of reasons. Various manufacturers developed their own protocols. Protocols from computer to terminal are often different from those from computer to computer. High-speed transfers of large amounts of data are handled by different protocols from those used with interactive terminals at lower speeds. With the proliferations of protocols, it's natural to ask, why not use just one protocol for all data communications? The answer is that each protocol is designed to solve a specific communications problem. Needs develop and protocols are introduced in the computer industry faster than standards can be developed and adopted. Even if all manufacturers could be persuaded to agree on some standard, maximum communications efficiency would dictate a variety of protocols. The transfer of large blocks of data just doesn't fit into the same protocol needed for interactive terminals which transmit and receive short bursts of data. With the many different protocols that already exist today, protocol converter products are needed to solve the problem of transferring information from one computer to another. Protocol conversion and recognition between many different computers can be performed inside the computer itself. However, the different applications of protocols continue to expand with the expanding use of computers. It's both impractical and often impossible to do all protocol conversion inside the computer. For this reason, there is a growing use of separate standalone converters. The standalone converter can be as simple as a device converting a single channel, or could be a computer dedicated entirely to protocol conversion for hundreds of terminals. A computer that can convert multiple protocols without impairing the speed or efficiency of the host computer. Standalone protocol converters perform a variety of functions and are implemented in a variety of ways. They may serve anywhere from a single terminal to hundreds of terminals. There are converters for batch protocols, for interactive protocols, for synchronous protocols, for asynchronous protocols. Here is a quick overview of some actual protocol conversion devices. This small box converts the electrical interface RS-232C to the Burroughs Corporation TDI, or two-wire direct connect interface. This electrical interface converter box has no intelligence. It does not change any of the data in any way. It only changes the electrical levels of the data as it passes through the box. Here are a pair of statistical multiplexers. They take asynchronous data in at one end, change the packaging of the data as it passes between the pair over the phone line. The data is then put back into its original asynchronous form at the other end. These multiplexers only change the data in the middle temporarily for the purpose of concentrating more data down one single phone line. If you look at the data just before it goes into the first multiplexer and then look at it again at the other end of the link after it comes out of the second multiplexer, there is no apparent change in the data format. You can only see the change for the moment it passes down the phone line. The protocol converters we will focus on actually change the packaging of data to enable computers using different protocols to communicate with each other. The typical protocol converter you will encounter has one single port connection to the main computer and one or more connections to terminals using a different protocol. These protocol converters often provide lower cost communications alternatives. They can also make installing terminals, connecting to the computer, and diagnosing problems faster and simpler. Protocol converters may allow a wider variety of terminals and printers to connect to a computer, opening up new applications. The typical protocol converter we will focus on has one port connected to the computer with multiple ports for connecting terminals. The port toward the computer typically communicates with a synchronous protocol such as BiSync, HDLC, or X25. These are usually polling protocols where each terminal device connected is expected to have its own address. There can be many of these address terminals on one computer port. Synchronous polling protocols work like this. The computer sends out a poll asking the terminal, "Are you there, terminal A1?" A1, if it's running, is expected to respond, "Yes." The polling is repeated in this order over and over again. The polled terminals send messages to the computer only in response to a poll. If not polled, the terminal can't send to the computer. These synchronous polling protocols allow many terminals on the single computer port. The protocol converter has many ports for asynchronous terminals, one port for each attached terminal. The converter talks to the computer on behalf of the dumb asynchronous terminals. The terminals are called dumb because they don't recognize and respond to polling addresses. The protocol converter responds to the addresses on behalf of the dumb terminals. The protocol converter is able to keep track of each dumb terminal and its address because there's one physical port on the protocol converter per dumb terminal. The protocol converter answers all of the computer's polls. The converter tells the computer that the terminal or port is there, accepts messages from the computer for the terminal, and formats and sends messages from the terminal back to the computer. This process makes more sense when you see a protocol converter actually hooked up to a mainframe. The communications is established and you see it compared to the alternatives. This protocol converter will be connected to an IBM System 34. The basic System 34 can have a single line communications adapter or a multiple line communications adapter for remote terminals. Remote terminals are connected using modems. Local terminals are connected directly to the 34 using coaxial cable. The single-line device allows one or two RS-232C interface communications lines, and the multiple-line device allows up to 4 synchronous RS-232C data communications lines. The standard terminal is the 5251 Model 12. Up to 64 remote devices can theoretically be attached to the System 34. The practical limit is less. The Model 12 terminal can have a printer attached too. 2 local terminals, the 5251 Model 11 and the 5291, can be attached to the System 34 using a special twin-axial cable. The System 34 user is limited to just these terminals. The 5251 Model 12 remote terminal and associated printer and the Model 11 local terminal are available from only 2 or 3 vendors. The only connections are the synchronous RS-232C remote terminal ports or the local twin-axial cable connections. With standard System 34 terminals and communications protocol, only 4 remote locations can be dial connected simultaneously. Modems for this application must be synchronous and usually run at 2400 bits per second or faster. A typical protocol converter for this application will be attached to the System 34 on the single or multiple line communications adapter RS-232C cable. The communications between the System 34 and the converter are synchronous. The protocol converter communicates with the System 34 just as a remote model 5251 terminal would. With the converter in place, it becomes possible to attach a wide variety of terminals to the converter, and thus to the System 34. Dozens of models of very low-cost asynchronous terminals can now be attached. The protocol converter ports, while supporting an almost endless variety of terminals, must know what type of asynchronous terminal is attached. The first concern is to separate receive-only printers from interactive send and receive terminals. Second, among the dumb asynchronous terminals, there is a wide variation in the use of special invisible characters or control codes used to position the cursor, set up reverse video control, the keyboard, etc. The protocol converter must use the correct control code so it always positions the data in the right place on the screen. Therefore, knowing the terminal type and matching it to the protocol converter port is very important. More and more users want to attach personal computers to computers like the System 34. This is easy and cost-effective with protocol converters. Almost all personal computers have asynchronous communications and have the ability, either standard or with extra readily available software, to emulate a variety of dumb terminals. One popular type to emulate is the VT100 and ANSI standard terminal. ANSI is American National Standards Institute. ANSI has published a standard for asynchronous terminals and their use of control codes for functions like screen formatting. Here is the most basic System 34 protocol conversion application. An RS-232C cable ties in the protocol converter, and one or more terminals can be directly attached to the converter. The next level of expansion involves one or more remote terminals with the computer and protocol converter. A 212 type 1200 bits per second modem is one of the most cost-effective modems. The modem is cabled into the same type of port in the converter that the local asynchronous terminals use. At the remote site, the user has the terminal and another 212 modem. To get in, users simply dial the phone number of the modem at the protocol converter, press a few keys to sign on, and they're on the system. If all the terminals were together at one remote site, the protocol converter itself can be remotely located with a higher speed synchronous modem. 4800 or 9600 bits per second synchronous modems are normally used to ensure good communications performance. In the case of the System 34, more than one protocol converter can be located remotely on a single port using a multi-drop line. The converters will act like controllers for remote clusters of terminals. Protocol converters can be mixed on the same communications line with the 5251 Model 12 terminals using multi-point data communications. They can even be located at the same site using modem sharing units. After the protocol converter has been located at a remote site, asynchronous terminals can still dial into the protocol converter using modems like the 1200 bits per second 212s. When the protocol converter is at the computer location and has a number of ports, perhaps 8 or 16, users soon encounter remote sites needing more than one device, like a printer and a terminal. For these needs, it's possible to use multiplexers on either dial-up or private lines to further save communications costs. Multiplexers provide users several benefits, including lower phone line costs, lower equipment costs, and error-free transmission. Error-free transmission is often a concern. The protocol used on the System 34 is an error-correcting protocol. Before statistical multiplexers, asynchronous dumb terminals had no error correction protocols or equipment available. Now, error-correcting capabilities are widely available at reasonable cost. Protocol converters have several additional aspects that are important and vary from converter to converter. The method of programming the protocol converter can include EEPROM-based programs, diskettes, direct modification with a local or remote terminal, or a combination method. This EEPROM chip is 64K and holds 8,000 characters worth of information. If a unit is programmed with this, the chip must be changed to modify the converter. If a unit loses power, the program is automatically reread into the unit from the EEPROM chip. With a diskette, the program is loaded from the disk. Disks are easy to make, easy to send in the mail. Easy for users to load. If power is lost, converters may need the disk program reloaded. If the disk program does need reloading, it's an easy process. Converters may have connections for a local or remote terminal to modify minor functions such as speed, parity, or terminal types. The major converter function is almost always contained in the EEPROMs or on the diskettes. Some protocol converters have an extra terminal port for local or remote diagnostic capabilities. The diagnostic ports allow local or remote checking for speeds, program modifications, and other functions. The number of ports on converters varies. Units may support 1, 2, 4, 8, 12, 16, or more devices. The trade-off is initial cost versus easy upgrading at a later date. For instance, if only 4 ports are installed on a box capable of 16 ports, the initial cabinet size and power supply may increase costs, but adding later is easy and cost-effective. The variety of terminal and printer types that can be simultaneously supported ranges from one terminal type per converter to a different terminal type for each port. The variety is a function of the memory and processing capability of the converter. Keeping track of several terminal types, all active at once, requires more protocol processor memory and more processor power and is reflected in the cost. The memory size is closely related to the performance perceived by the terminal user, too. If terminal screens all share one single first-in, first-out buffer, the last terminal's screen data will be stacked behind data for other terminals. A bottleneck can be created. Other protocol converter functions that are available on some units are automatic outward dialing, color terminal support, multiple protocol support. Automatic outward dialing can be used either to collect or to distribute data. Data collecting might include cash register data. Data distribution could include telex messages or electronic mail. Color terminal support is becoming more popular. Color terminals are especially helpful when displaying graphic data. The list of protocols and protocol converter functions is certain to continue to grow. Capabilities will continue to increase. Converters will continue to become easier to install and use. As you just saw, the physical installation can be as simple as plugging the converter into the computer and the terminals into the converter. This ease of use is good news to you as users as the need for protocol converters continues to expand.